Welcome everybody. Thank you for coming. My name is Aviad Tamir. I work for data and integration team of group architecture for Nordea Bank. Today I want to talk to you about building a collaborative enterprise data platform, right? Effectively, you've got teams of individuals spread across your company that have to work together in some meaningful way. You need them to be able to access and share the data, talk to each other, and build things together. So how do you enable that? We're going to walk through some of the ways we are running things at Nordea. And I will probably share our experience. And first, I will tell you briefly about Nordea history. Hopefully that would help to understand some complexity that we have. And second, I will introduce a hypothetical team that represents different stakeholders who work with the data. We will look what tools they use, what they have in common. Then we will jump into architectural assessment. Probably spend a little more time there. And finally, we are going to talk about how we empower business stakeholders, how we enable collaboration, how we build maturity towards embedded governance. And I'm probably going to trivialize a handful of things, but stay with me. I hope it will all make sense as we get to it. And at the end, I probably will try at least share a couple of tips and little things that could help to build your data platform. Does that make sense to everybody? Head nods? Okay, good. Let's meet Nordea. So, our family tree of around 300 banks includes some of the oldest banks in Nordics. And these banks pioneered kind of commercial banking industry. So they kind of were merged, and by the 1980 we were 30 banks, and I think by 1990 it was down to 4 banks that all merged in 2001 under the brand name of Nordea. And I was told that the origin of the name is Nordic idea, so Nordea is Nordic idea. So as you can imagine, merging all these 300 banks brought a lot of challenges. They all have different IT systems, they all use different tools, they all had different business processes, and even, some basic things like semantics and definitions that they use for customer contract, they were different. So as you can imagine, if you have one system and one set of definitions for kind of critical business entities, let's say you fixed all the data quality issues and kind of everything works good, but now you add another system and probably similar semantics, but these two systems have to exchange the data, right? And the definitions might be a bit different. So when this data travels from system to system, there is a place for error. Now, it's only 2 systems. If you bring 300, throw them all to the mix, you can imagine what happens, right? So let's see how the average team at Nordea is structured. I kind of took this example because I think it illustrates quite well about 90% of the cases. So this example comes from the world of credit risk and fraud detection, right? And it's not the entire bank, of course, as I told you. So there are a few kind of roles that represent different areas in the data pipeline. The color coding, I will get into it in a couple of slides, and you can see that some folks here are located closer to the source systems, right, the green one. So you have here data steward, data asset owner, and application owner. They all use basically different IT and business monitoring systems. They monitor their data that goes out further down the stream. They need to make sure that the system that send the data to the entire group performing well, that they hit the KPIs and everything works smoothly. But mainly it's monitoring tools and some internal tools that help fix data in case there is a need. When data goes further, there are kind of this blue team. That's data ops and data engineers. They make sure that the data can move in the organization to all the consumers. So the tools they use are more kind of on an infrastructural level. They probably use Hadoop, Java, Spark, all kinds of Linux and Unix shell scripting. And their task is more or less to make sure that they prepare the data and bring it through the ingestion framework to the shape that it can be consumed by the consumers of the data. So, for example, the task could include ingesting transactions from kind of credit card transactions from previous day, aggregate them on account level or customer ID, and then put them into some place where it can be imported into relational database. And from there, it could be consumed by different credit risk models or fraud detection models. Some variables can be calculated and so on. So they kind of mostly care about performance, availability, heavy lifting, moving the data. And finally, on the right, you have the team that is closest to the business. These are the consumers of the data. There are some business analysts who not very technical, but they know a lot about the business. They help to develop different objectives and models and variables that are used to run the business, to assess credit purchases and make sure that only kind of genuine transactions get through. Next is data scientist. That's the people who develop new models and make sure that current model performs, that the approval rates are intact and we don't reject too many good customers. And of course, application developer, because this data that is prepared by the folks in the blue team, it needs to be not only in the shape that is easy to consume, it needs to be presented to the business users in some way that kind of easy to structure and see if we hit business KPIs. So the application developers use more front-end tools like Node.js, Django, and all these front-end development frameworks. Data scientists might probably use different labs and different notepads and RStudio. Business analyst basically consumes the information that is available in the dashboards that application developer built, and also might use some kind of relational databases to do some analytics. So what all these folks have in common? That's kind of very interesting, because what they have in common, they all use different data sets, they all use different formats of the data, and they all use different tools. It's kind of, yeah. So they have to find their data, they have to find data owners, they have to figure out what are the relationships among different data sets, and yeah, and they have to manage all this by themselves. Does that sound familiar? No. Well, here's a question. Is there a technology that can solve this kind of problem? Some kind of turnkey solution that can just quickly fix everything? Maybe Hadoop, or I don't know, cloud, microservices. Blockchain, anyone? No. So these technologies are evolving, and I think they are changing every few years. and it's even hard to keep an eye on and keep up with all the current trends of technology. But people tend to over-rely on technology, believing it could solve all the business problems. Unfortunately, that's not true, and I think all previous speakers also mentioned that. So technology, it's a tool that can help, but we shouldn't rely on the technology only. So many kind of tried the approach of jump on evolving trend and migrate all the business to kind of bet the house and migrate it on the trendy one. In most cases, this lift and shift didn't work. But wait, if the technology cannot solve it, what can? And I work in group architecture, so we in group architecture think, surprise, surprise, that the solution isn't the technology, but rather the architecture. And our role is to support the organization and kind of help to realize the business strategy. And we need to make sure that we have right technologies, that we have good system design. And we're also responsible for creating architecture vision and roadmap and also some governance process around the architecture, how all the business initiatives on board, what technologies they use and how they fit into our current landscape. So let's take a look at the architecture. Where does the architecture assessment start? Right, we start with analyzing business requirements. So I brought this example that was in the very beginning of my work with the team, the kind of hypothetical team that I showed you. That was the list that kind of grew very quickly, but I rather like the short one that can fit into one slide, because I think it first of all, it illustrates the idea. And yeah, it was fairly quick exercise. And well, let's see what it has here. So mostly it's focused around data cataloging, ability to search and access the information, and self-service. I'll touch upon self-service, it's kind of funny. Storage. Good storage medium, persistent storage, traceability, which means lineage, different types of lineage, and maintaining the performance of existing current models and also kind of testing the champion models. So that was the set of requirements. And kind of self-service is a bit funny because to me self-service, of course, it's a bit of a buzzword, and self-service means that you need to be able to figure out how to use the data without talking to anyone. Well, to me, being an Israeli, it's kind of hard because I like talking to people. And like I probably, if I don't know something, I would go and ask my neighbor before Googling it. So yeah, but self-service is a good thing. It kind of sorts the mess and helps empower business users. Because if you have ability to figure out yourself how to use the information, it makes your job a little bit easier. So now when we have analyzed the requirements, let's start cutting our data platform into components. Yeah, so here you can see kind of that following the discussion with our stakeholders, we did several rounds of requirements analysis from many other areas in the bank, and we grouped them and we prioritized them, and we created our data strategy that resulted in reference data architecture. Kind of high-level picture that color codes different areas according to their role. The high-level picture aims to have all necessary components, so that's kind of all necessary components of modern data platform. Let's take a look on key capabilities that it delivers. All right. So on the top you have a green box with all the data sources, In the middle, kind of blue area, is the storage medium and data services around it. The purple part is BI and analytics. The orange and yellow on the right side is more about data processes, data quality, data governance, everything related to it, kind of glossaries, things that more on the process side. And the pink on the bottom, it's more about data culture. So that's on a kind of in a nutshell what we try to build. So let's take a look on the capabilities. The key capabilities that were fundamental to our data platform. So as I mentioned, the green area, it's data quality. There you need to establish a good control on the quality of the data that comes into the system, right? From all the sources. Yellow and orange is tied to data governance, auditing, and regulatory compliance. So it's very important to support all the demands from the regulators, have a good control what happens to the data when it travels inside the bank or inside the organization. The blue area is kind of, the description is brief, but it's very big chunk of work. It's storage medium and all the data services around the storage. And the purple support all BI and analytics. So yeah, the pink area I mentioned, it's a cultural, data culture. So this reference data architecture is fairly high level again. And in order, the idea is that it could fit into one slide. So it's easy to illustrate everything that is connected to architecture using this picture. So I suggest we drill down a bit and see what components this data platform contains. And here we took a bit of top-down approach and structured the data platform in 5 pieces on the top level. So you can see on the top level it includes level 1, we call it data acquisition layer. It's kind of logical grouping, a container where all the capabilities related to collecting and storing the data will reside. And just to mention, here you see only level 1 and 2, right? And on level 3 and 4, it gets a bit hard to see what you have because there are hundreds of components. So I decided to present only the top level components. So again, on the left you see data acquisition. There you have the 4 different flavors of data ingestion. It's important to be able to have real-time ingestion, incremental ingestion, kind of batch layer, and also ad hoc capability to ingest the data. And the consuming part, or data access, is on the right. Here we group all the consumers and how they access the data. And here you need to support ad hoc querying, analytics, reporting, discovery, data labs, and different types of dashboards. On the bottom, there is platform services, but it is a data platform, so I think we can kind of change it a bit and say that it is more infrastructural services, the services that data platform consumes from the IT. It's basic things that would exist inside the organization even without data platform. Basically networking, security, communication, workflow management, capacity management, logging, monitoring, and operational support. So very infrastructural things. In the middle, you have a data storage medium, and on level 2, only different types of storage specified, so no services related to data. So we decided that we need to support raw storage, meaning that kind of file-based, we just take data as is and store it somewhere in a very efficient way, in a very efficient medium. And then we can, of course, enrich it, combine with different types of metadata, master data, and put it in a more structural way. for relational databases like data marts, data warehouses, and operational data stores. And of course, we need to have fast access, like very expensive, where when you need performance, then fast access storage is used. For the old data, that is, we call it a cold data, and there are like different viewpoints on this design. So we have this multi-temperatural storage. So cold data is archived, and it's kind of cheap storage that doesn't have to be fast. And that kind of completes the picture here. And of course, you can structure it as it fits your organization, but we believe that fits any organization, or at least as a fundamental set of capabilities. On the top, the last but not the least, data management. So here we do process and integration, right? And here we need to take care of data quality. We need to have information catalog, and in order to have information catalog, we need to have metadata and manage it. Very important. We need to be able to transform the data, and of course, master data, very important for the bank. We need to have data APIs that help us to exchange data among the systems. Calculation and computation engines are kind of maybe a bit special because they're mostly used in a bank due to the nature of the banking. They're end-to-end solutions. They are just kind of, that's how the things developed organically. And on the top of everything is data governance. There is a reason for that. So let's talk a bit about data governance. What are the expectations from data platform here? I think that if I try to summarize, everyone expects to be able to understand and share the information they use. They want the information to be secure and access to be monitored. Also, it's important that we know the origin of the data, right? What system it came from, because often we face the situation that the same data comes from two different systems and kind of overlaps. So it's important to know the origin of the data. So how do we enable that? Yeah, and here I put a very nice picture that helps you to figure out where you are in this journey of building embedded governance. That's what we are trying to achieve, and I think today we are somewhere in the middle. Of course, data citizenships looks like a dream from where we are today, but the more you do kind of improve things incrementally, situation becomes better. So how do we enable that? I think that's kind of where it gets interesting. We found the tools. We identified the sources of our information, all the data sets, and we know all the workloads. We took inventory on kind of all the data sets, but there might be a lot of them. How do we actually find the things we are looking for over time? This is where metadata is really important. So you can probably kind of guess where I'm going to. We are going to build catalog. The catalog is going to drive everyone's usage downstream and everyone's ability to work on their own, the self-service. In order to build the catalog, you will need to agree on metadata. That's very important. That's kind of one of the key things. Here's a little something that I thought would be very interesting to show. And this is project Egeria. And Egeria basically helps organizations to share, exchange, and govern metadata. I think it's quite a good tool because it's agnostic to the technology, first of all, and it helps to share the metadata among different applications. It's very slim footprint, it's open source, Linux Software Foundation. And it is good from two perspectives. From the business perspective, it comes with predefined set of roles related to data governance. And from architectural perspective, it uses all the modern kind of architecture and technology inside. So it's based on microservices. It uses Kafka to exchange messages. So we believe it's good to use it in order to be able to scale and kind of have metadata governed. So in conclusion, I wanted to share a few little things and tips that I collected on this slide. I hope that you will keep them in mind when you are going to build your enterprise data platform. So it's not about storing the data, it's about using it. The use drives the architecture. Understand how your system is used to drive decisions. Also, it's important to put the data in the center, not the technology. Right? Technology should not dictate what you do and how you do it. And probably the most important recommendation, get the metadata and the cataloging piece fixed right from the start.
Thank you very much.
Thank you.